In this video, we're going to go through navigating the unit circle and finding angles which are presented in radians quickly. Here's a picture of the entire unit circle well, really, there's a whole bunch of angles in the unit circle, but there are certain angles which are special. The first special angle is, well, let's say 0 radians, and then the next special angle is pi over 6 radians. In degrees, that's 30 degrees, and so on and so forth. And this is actually, all in all, this is a lot of data. You'll notice, of course, using reference angles and so on, that you'll see the same numbers other than plus or minus signs appear, like here and there. And so you can use a lot of the symmetry to help you out, but I think one of the key places that it's easy to get stuck quickly is, well, finding the angle in the first place. So how are you supposed to memorize all of these numbers? And I would suggest that you don't. These slides will go through a method of navigating the unit circle quickly. So given an angle, which is one of these special angles on the unit circle, how do you locate theta quickly on that circle? Well, if theta is in degrees, then you can use 0 degrees, 90 degrees, 180 degrees, and so forth. You can use these as anchoring points, just use the x and y axes to kind of help, and you can go, well, okay, I've already traveled 180 degrees, and then subtract to figure out I still need to travel 30 degrees more, and that'll get you going. But in radians, this is trickier, especially with all the fraction subtraction, so I have a better idea. Now, if you go through these slides again, or just look at a unit circle, you'll notice that the denominator is always 2, 3, 4, or 6. So the first thing to do is just memorize. I mean, if you want to always compute these, that's fine, but I would just say memorize these several conversions, all of the ones that are in the first quadrant. And, well, here's a simplified picture of the unit circle. I've gotten rid of, I'm not trying to say that, this point is 2 pi or something, or that this point is pi over 6 radians, but, I'm just showing, just labeling the angle next to the point. So the point is to not try to memorize all of these in order. I think that's a silly idea. I think there's something much faster you can do. So what I'll do is I'll remove some of these, and we're only looking at anything of the form something times pi over 3. So you have 0 pi over 3, then 1 pi over 3, or just pi over 3, 2 pi over 3, 3 pi over 3, which simplifies to pi, 4 pi over 3, 5 pi over 3, and then 6 pi over 3, or 2 pi. So this is how you can just quickly navigate through any angle which is something pi over 3. Imagine a pizza with 6 equal sized slices and just travel around like this in a sixth of the circle at a time. Here's the entire picture again. So just in context, if we go back and forth, I hope that helps. That the point is we're skipping some of the other angles here. And now what I'd like to do is look at multiples of pi over 6 instead. So something times pi over 6. So there's 1 pi over 6. There's 2 pi over 6, so we're rediscovering this 2 pi over 6 or pi over 3 from earlier. And that's, well, that's fine. But you have pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2, 4 pi over 6, which reduces. And you would have already seen this earlier with the divide by 3. 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. So even if you want to do this without saying the pi over 6 part, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a pi over 6 angle, what it does is it cuts this circle in 12 equal sized pieces. And again, you can just keep traveling through, and you will rediscover the angles that we have already seen. And you'll also rediscover, or you'll discover for the first time using this method anyway, the over 2's here on the y-axis and the, well, over 1's here. And that's fine that you're rediscovering some angles. Finally, with the whole picture back, let's do this when you have something pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Of course, some of these fractions reduce. I didn't even bother saying that so that the pattern is a little bit more apparent. But now if you go through, we've actually covered every single angle here.